Hi, can anyone hear me? Cool. I can't hear any of the audio. So this is by far the biggest stage I've ever seen in my life, in terms of this side of the stage, you know. Normally, when I worked at React training, I did a lot of workshops, 10, 20, 30. I think at most we had like 50 people in one of my workshops, and there's a lot of faces here. All are scary. So we're gonna see what this looks like. I was also told there were a lot of Vue developers here. Raise your hand if you're a Vue person. Yeah, so I didn't do enough research. I think I showed up assuming there would be a lot of React folks here. And so I was like, oh, cool, there's a bunch of Vue people. If I screw up and don't get things exactly right, everything's gonna be fine. They can't call me on it, so it'll be great. And then they said they were doing the React documentary, and surprise, there were some React core team members spread out around here too. So now I'm like, okay, I really have to know my stuff. So yeah, let's hope it goes well. But yeah, today I'm going to talk about how we can build faster front ends by looking at our back end performance. And we're not really talking so much about getting into the details of optimizing your back end, but really like how we can take some of the patterns that expose more of the back end to the front end as that gap has sort of narrowed over the course of many years. So, you know, like on its face, it might seem obvious. If your back end's faster, you can make your front end faster, your whole app's faster, right? But I think the two sides of the stack are connected in ways that are often overlooked, and our users will experience janky, slower apps as a result if we're not careful. So if you are a front-end developer, this is probably the kind of thing that you are focused on in your work, right? It's user-facing, and you want to make your users happy, right? So before I talk about all the juicy perf stuff, I really want to talk about what is a front-end developer? Like, we're all probably front-end developers. Most of us are front-end developers. It's a JavaScript conference after all. But what does it actually mean to be a front-end developer these days? Like, I don't know if you all feel this way, but I think it's become pretty ambiguous in some ways. As front-end JavaScript developers specifically, we often find ourselves working with what we used to think of as back-end code, right? Or at least the problems that we run into in our applications that we end up having to debug are problems that we used to kick off to back-end engineering teams who worked in a lot of different languages, software stacks, that sort of thing. But how do we get here, and what opportunity do we have as a result with the state of this ambiguity? So a few years back, a fellow by the name of Chris Coyier, anyone heard of Chris Coyier? You may know him as one of the founders of CodePen. He also started CSS Tricks, which I think we all probably use pretty regularly. Does anybody find themselves bookmarking the like crash course in Flexbox article? Like, it's one of the best on the topic, and like in the early days, I think I spent the first year of learning Flexbox just going back to that article. It's fantastic. So Chris gave a talk that I really loved. It's called "Oops, I Guess We're All Full Stack Developers Now." It's a great talk. Highly encourage you to watch it. I threw this link up, chance.dev/JSWORLD, with just a handful of links that I'll reference throughout the talk. So pull that up if you want to look at any of the references I make throughout the talk. But he also wrote a blog post exploring similar themes called The Great Divide. Really big post. Anyone read it? It's a great post. But his focus was it was kind of in the divide between front-end developers who focus on JavaScript on one side and those who focus more on HTML and CSS on the other side, and sort of lumps accessibility in there as well. It's really interesting to me because these are all focus areas within the same domain in my mind, but over the years, in the JavaScript side of things, like I said, we've been sort of exposing ourselves more to what we would typically look at as back-end development, and that sort of created this rift in another side of the front-end stack people who don't necessarily feel as comfortable in that space, and they feel like they are pressured to do things they're not necessarily interested in order to feel like they're up to par. And he talks to several leaders in the front-end space who talk about this evolution and how he sees this rift in the community. And I totally understand where that feeling comes from. I've felt that in the past, and I sympathize, but like my first love language is CSS. Like, I come from that world. I was a designer in a past life. And I'm a huge advocate for accessibility and semantic HTML, so I get it. But I think the underlying shifts that we're seeing in this field that are creating this rift, I see them a little differently. So, first of all, the idea that of a front-end developer and a back-end developer being fundamentally different things to me, I see that mostly as a product of early constraints that we faced on in the old days, and sort of these like different, I'd say somewhat flawed models of separate concerns, keeping things separate, right? Like the MVC patterns of that we used to work in and love. And what do I mean by that exactly? I've always called myself a front-end developer. That's because the things that I care about most on the web are the things that the user interacts with and interfaces with, the things that they see, right? And so what did I focus on in creating these user experiences? Well, I focused on the UI, right? Like I focused on CSS, on making things look really nice, bringing a designer's vision to life, because that design is really important to the user, right? And I focused on HTML because good HTML often results in good accessibility, and I wanted those users to be able to use my products as well. So these are the things I cared about, and I thought that, excuse me, I thought that the users really cared about them too, and they do. But I didn't really think much about things like databases and servers and all of these things on the other side of the stack that I was sort of afraid to dip my toes into. Because I didn't really think that the users cared about that stuff, right? They don't see it. They don't touch it. They don't know it's there, really. But that's not really true. As the major problem with this working assumption, the user cares quite a lot about those things. They don't know it necessarily, but I actually think they probably care more about that stuff than they care about how nice the buttons look, right? Or how close to the design system we get all of the different components. They're not going to say it that way, but if their bank account balance goes to zero because somebody dropped a database table somewhere, they're going to panic, right? Like that's a problem. If they go to checkout on an e-commerce page and the checkout flow is taking like 10, 15 seconds to load, they're probably going to leave and go buy your product at the mall or something. It's not worth their time and trouble. So these sort of things on the back end actually really matter to the users. And they're front and center for the user, so why are they not front and center for us as front-end developers? Like this is kind of a concern for what we care about, which is the user. Well, in the old days, it made sense, right? Like there were these very different technologies powering the back end. We had these very different languages that people had to work in, and the tooling was not really great for working on both sides of the stack in the same application. Like think of anybody working PHP like I did. I used to build apps in Laravel, and Laravel is a great tool, don't get me wrong, but like you're jumping back and forth between languages, your context switching, and Laravel is like an improvement on what we had in the really old days where you were drag and dropping files over to the server with Cyberduck or whatever. So, but it was really tricky to work on a full stack application as a single solo developer without knowing all of these different contexts. And in the really old days, you didn't really have web apps the way that we think of them today. Like if you had a lot of functionality in a web app, it was probably an embedded Flash animation, right? So obviously that went away. The web standards started to mature. We were able to build more fully powered web applications with JavaScript, HTML, and CSS. And then we get Node, right? Like I think this was the first big step in blurring the lines between the front and the back end and bringing us closer to the center. And suddenly our entire application could be written just in JavaScript if we wanted. Some of the code could actually run in both places, which is super cool for a lot of reasons. But front-end developers who were already writing their JavaScript could now easily jump back and forth between the back-end code and the front-end code and sort of get an idea of what's going on, and in most cases kind of learn how to work in the other side of the stack. And that was, at least for me, that was really revolutionary in sort of starting my journey to looking towards what it would mean to work more on the back end, right? And we take this for granted, but I think this is one of the coolest things that happened for the web. So round of applause for Node. I'm stoked about the fact that we have, still today, right? I don't know how old it is at this point, but it's awesome. And props to Node and for paving CowPaths there. And then on the front end, right, like we were still seeing all of these seismic changes happening on the front end too. We get frameworks or tools like jQuery that make working in the DOM and manipulating the DOM very easy compared to using JavaScript pre-ES6. We start iterating and creating these ideas about components and all these new frameworks like Backbone and Ember, Angular, and then, of course, React, right? And just like Node, to me, React was super revolutionary. It was a seismic shift in how I work day to day. And it challenged many accepted patterns on how we model our applications. It told us that instead of trying to keep all of this DOM in sync with our application, our UI state, we could instead just throw it away and create a new rendering of that application every time the state changes. Like, we could react to those changes, right? This core idea of reactivity, it seems to have stuck, and we've continued to redevelop it and reimagine it now in other tools, like obviously Vue, Svelte, Solid. But these frameworks didn't just challenge us on the front end. These frameworks also provided APIs for rendering apps on the server. And this gave us a foundation for building these full stack frameworks that continue to bring both sides of the stack closer to the center. And so that's where I want to talk about Remix. Now, Remix, I like to call it a center stack framework. It is kind of a full stack framework, but we try and really embrace the fact that these two sides of the application are now closer together, and how can we lean on that to create APIs and patterns that make you really productive and are able to ship better, faster websites. And we're a JavaScript framework focused on web standards. Our stated mission is simply to help you build better websites, right? We look at HTML and the HTTP specs, and those design decisions and APIs, right? So we try to strike a balance between simplicity for you, but also making sure that we don't over-abstract the underlying technology, so it's easy for you to jump in and fix problems when they arise without things being buried within 30 subfolders of node modules. So I'm talking about Remix primarily because I work at Shopify now. I don't know if you heard the news, but it's really weird to say that. Like, I've worked for startups for a long time, and now it's like I work for this mega huge. We had like 7 coworkers, and now I have like 7,000 or maybe more. I don't know. It's pretty wild. So yeah, but we're still building Remix. We're using it to power some of Shopify's internal tooling. They just launched Shopify.com, their new iteration of that site on Remix. So really embracing that and moving forward, really excited about the future there. So how does Remix help us build faster backends to help you build faster frontends? Well, the first answer lies in the route APIs. So let's look at the anatomy of a Remix route, because to me, the Remix route is sort of the heart of everything that is Remix. So we take a look at this. Am I the right slide? Yeah, here we go. So this is a route module. We've got a few different things here. The first function that you see at the very top of the file is our loader. It's just called loader. It's an asynchronous function, and it is only going to run on the server. And this function is going to be called every single time that a GET request is made to your route, no matter if that GET request is being made through directly through a tool like Postman, or if you visit the page in your website, that loader is going to get called. Right? You can handle that however you'd like to, but it's simply a wrapper over a request handler for that URL. And each route represents a URL, just like if you're coming from a framework like Nuxt or Next, it's the same kind of concept, right? So your loader is going to get called on every page load, anytime a request is made to that endpoint. And then we have, below that, we have a default export, which is your route component. And this represents the UI that your user is going to see when they visit that page. Now, this component is actually optional. You can also create what you call a resource route, which is only going to respond to requests and not render any actual UI. And all of the async work is happening up here in your loader, and it's only happening on the server. So you can handle all your database queries here. You can handle requests. You can use it as sort of a proxy server, so you can hit other endpoints. But you get to control the performance here because you're not depending on the speed of your user's device by running everything on the client. You get to sort of control that. So if you have a really awesome, fast, performant backend, you say you're running on the edge, then you can do a lot with your loaders and never have to ship, in some cases, never ship any JavaScript to your client. You don't even have to ship React to your client if you don't want to. You can, like, rendering React, or hydrating React rather, is totally optional in Remix, and it's really simple to sort of toggle it on and off when you need it on a per route basis, which I think is really cool. And also, if you notice, if you look at this, the route component, I go back a slide, you'll see that when you actually call, so you call use loader data to access the data that is sent in the response if you notice in our loader, we return a new response. This is just a web standard response object, no abstraction there. And we are just sending a string with all of our data, and that response comes to our browser, and we can access it directly. There's no asynchronous data loading here. There's no spinners. Like, as soon as that response comes in, we have the data, and then we can start working with it, right? So, yeah, we don't have to manage any of the complexity in our UI state because our loader is handling all the asynchronous work for us on the server. You can send a cache response so the browser can have that stuff ready to go. So you can cache on a CDN. All of the things that you can do to optimize your app on the back end, you now have full control over right there in your app, in your route, right? I think that's pretty cool. So another thing that I think Remix does to help us out a little bit is this idea of nested routes. So every route can have its own loader file or its own loader function, and we also support the idea of nesting routes. So in your routes directory, say we've got a blog, and within that blog we have a post ID, starts with a $, which means that's a dynamic route segment, and we can check to see if that post exists and return a response accordingly. You could have a subcategory or a sub-page of categories. And what's going to happen here is we're going to actually call the loaders for every single route in the route tree. And then we're going to call those in parallel, which sort of automatically optimizes a lot of your backend code for you without even have to think about it, because if you're doing some expensive query at the top of your tree, if you're doing another query in your blog root, and then you're obviously looking for categories in the categories page, we're going to run all of those requests in parallel. So we're doing a lot for you in terms of managing that complexity so you don't really have to think about it, which I think is also pretty sweet. Another thing I think that is really cool about all of this is this idea of co-location, right? Like, this is something that React and other component-based frameworks give us. It's a big selling point, right? Being able to co-locate a lot of our business logic and our views. Going back to what we were talking about earlier with separation of concerns, we've sort of changed how we think about separation of concerns. And I think for the better, right? Like, we now have a full picture of what's happening at a given point based on just looking at a route file, and not only in the component itself, right? We used to think of this just as a component level abstraction, and now it's like the server client is now co-located in a way where these are actually kind of the same concern, right? You're dealing with your data loading, you're dealing with caching, and you're dealing with how you process, interpret, and render that data, all in the same file. So if you need to make little optimizations, I think it's relatively easy to see where those improvements can be made. So let's say we're looking at this loader, right? We're doing two things in this loader. We're looking to authenticate our user, and we are querying for a post, right? Let's say, for whatever reason, user visits this page. It takes like 600 milliseconds or whatever to load, and we look at that. That's a problem, right? Like, we think that, we could make this faster. Just looking at this code, knowing nothing else other than what we've talked about so far, who wants to tell me quickly what we could do to possibly improve the speed of this loader? Anybody? Oh yeah, there it is. Promise.all. We can actually run these two calls. They're not dependent on one another. The user is completely separate from the post. We don't need the user to fetch the post. So we can actually just wrap these in a promise.all and query them at the same time, and now they'll run sequentially, so that once both promises resolve, then we can return that in the response, and now we've suddenly improved the performance of our application. And imagine this scenario, like, you may have heard of React server components. You'll probably hear a little bit about them tonight if you haven't in the documentary. At least I hope you will. They're really cool. We solve sort of the same kinds of problems, or at least we think about the challenges that React server component solves in a slightly different way. I imagine these sort of things like embedded in components. Say you've got a user avatar over here, right, that needs to have the user information. And let's say you have a server component and you are doing a request right there in your component. And that component lives over here in your components folder. And you've got your blog post component over here that is fetching your blog post, right? Now these things are sort of far apart. And there are ways to deal with this React server components, and tools like Next, who have started utilizing this in Next 13. But at least from my perspective and what I've seen so far, it becomes less obvious to the developer how to find and identify and solve some of these problems. And so for me, the idea of co-locating all of these concerns right there in your route is, it makes these kinds of issues really easy, quick to find, debug, and fix to increase the performance of your application. Now, let's say you have an async call in your loader that is extremely slow, and you don't want to actually throw that in your promise.all, because let's say in this case you're authenticating your user, you're getting a post, but you also need the comments for your blog post, right? And you don't want to chunk that in there because maybe you've got 10,000 comments and it's just a really slow query. And also your comments are probably at the very bottom of your blog post. You don't need to see them right away. They're not really pertinent to the rendering of the rest of the page. So one thing you could do is you could go in, you could just fetch them on the client, right? And throw a loading spinner up there and just render them later. You could do that, or you could embrace the fact that React now supports React. As of React 18, we have first-class APIs for streaming HTML, and Remix is able to embrace that, and we've built a few nice tools on top of that. So in this case, what we're doing is we're still awaiting our promise.all, we're awaiting our user authentication, our post, but we are also initiating the request for our comments. But you notice I lied, because I did write await. That's a typo. Ignore the await part. So that's supposed to be an unawaited promise. Pretend that's not await. We don't await the promise, but we actually ship the promise across the wire using this defer function. And what's going to happen here in our UI when we go to use that, you'll see right here at the bottom, instead of just rendering the comments immediately, we're actually streaming those in from the server. So so we can render this page faster. We can have our post information, our user information, but we don't have our comments right away. So in the meantime, we use React suspense to render a fallback. And then once we get through that suspense boundary, we use this component we give you called await. Think of it just like async await. And once it resolves, once the loader data.comments are resolved, we can then render those as we would. So we have a fallback UI, we have an error UI, and we have the actual comments rendering without managing any app state, without calling useEffect, without any complexity in our actual component code. And I think that's also pretty cool. I'm very excited. This is a new feature we just shipped a few weeks ago. Super stoked to start using this. Another really cool thing about Remix is that just like with mutations and GET requests, we also have a first-class API at the route level for handling mutations. So any other request types, your deletes, your posts, your patches, your puts, all that stuff is handled by exporting an action function, which has the same API as your loader function. But anytime I make a request here, I can authenticate and make sure the request is valid. I can validate my data. You should always validate your data. Don't ever trust the client, as they say. Once I have my data, I can do all of my database operations or any requests or queries that I need to make. And then just like a loader, I send a response. In this case, we're just redirecting to a new location with the newly created post. And this also, I think, removes a lot of complexity from how we have to think about manipulating data. And Remix provides a lot of really cool APIs. I don't think I'm going to have time to do the live coding portion of this, so I can show you this in action. It's kind of a bummer, but I think this is probably one of the coolest features in Remix, I think, are actions. So there's a lot more to it than this. Remix also handles a lot of the inherent complexity that we might not necessarily think about with these things. Let's say you have a combo box component, and I'm over here searching for, throughout a list of, say, 10,000 locations. And I'm just searching, I'm searching. And every keystroke is initiating a request to our server because all this information is on the server, right? Potential problem here, because I'm typing pretty fast, right? Race conditions, anyone? Like, what happens if I'm typing something and I get a response from like something I typed 2 seconds ago, but now I've typed a new letter and nothing matches up in my UI? Like, Remix handles all the cancellations for you by default in our loaders and actions, removing so much complexity. Like, I've removed so much code from so many components that used to have to deal with that kind of thing just because of how we handle those things in Remix. So I'm pretty stoked about this. Come see me after the talk if you want to chat about Remix and see some more demos, because I didn't have time to show you those. But yeah, really appreciate the time. Thank you very much.